Today we're going to talk about fractions of a set. Fractions can name part of a set. In this set, there are 1, 2, 3, 4, 5, 6 parts altogether. We can create a fraction for this set. Now, what if I want to know how many yellow discs there are? In this box, I'm going to write the fraction of the shapes that are yellow. So let's focus on that first. Now, in order to write the fraction of yellow discs in this set, I need to first find out my denominator. How many shapes are there altogether? How many colored discs are there altogether? Well, there's 1, 2, 3, 4, 5, 6. 6 is my denominator because it tells me the total number of equal parts. Now, if I want to know how many of the shapes are yellow, my top number, or my numerator, is going to be the number of yellow discs. 1, 2. 2/6 of the shapes are yellow. Now this here where it says 2/6 of the shapes are yellow, this is called a fraction statement because it states the fraction for the parts that we're counting. So it's called a fraction statement. And you are going to see that in your workbook, fraction statement. Let's take a look at another fraction statement that we can write for this set of colored discs. So again, I'm going to draw my big rectangular box that will fit my fraction of the shapes are, and since we did yellow already, now we're going to do red. What is the fraction of the colored discs that are red? Well, again, we need to figure out our denominator. Our denominator is the bottom number, and it tells us how many colored discs we have in total. If you remember from the last fraction you wrote, there are 1, 2, 3, 4, 5, 6. There are 6 colored red, or 6 discs altogether. The top number is our numerator. These are the things that we're counting. Right now I want to count how many colored discs are red. So now we count. 1, 2, 3, 4. 4 of the colored discs are red. So the fraction of the red discs is this. 4/6 of the shapes are red, and that's the fraction statement for the red discs in this set. Okay, what if we look at something different? Instead of looking at discs from Connect 4, what if I did flowers? Let's take a look at the flowers that we have available here. Okay, I have a collection of flowers in this set. I want to write a fraction statement for one of the colors in the set. How about we focus on blue? So I want to know what is the fraction of the set is blue. There's my fraction statement. Here I'm going to write my fraction. Who remembers what the first step is to writing this fraction? First, I need to find my denominator. That's the total number of parts in the set. Well, let's see. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 parts in total. I want to count how many parts are blue. In my fraction statement, I need to know how many are blue. 1, 2. There's only 2 parts that are blue, so 2/8 of the set is blue is my fraction statement. What if I want to know how many parts are green? Well, again, I need to find my denominator, which is my total number of parts. Can you find out the total number of parts by counting? That's right, there's 8. Okay, since we're counting green, who can tell me how many green parts there are? If you said 3, you were correct. So our fraction statement is this. 3/8 of the set is green. I can look at this in another way. What if I count the number of red flowers in the set? What is the fraction for the red flowers in the set? Well, again, what's my denominator? It's the total number of flowers in the set. We have 8. Okay? How many are red? The number that we count goes on top. As you can see, there are 3. 3/8 of the set is red. Okay? So that's using flowers. Let's take a look at one more item. How about some rocks, things that you find outside? All right, I want to write a fraction statement for this collection of rocks. First, let's find out how many of the set is black. So now we're going to look at the black stones. Well, first we have to find out how many stones do we have altogether. If you said 4, you were correct. We want to now count for our numerator how many of the stones are black. 1, 2, 3. If you said 3, you were right. So I can say 3/4 of the set is black, or I can also say 3/4 of the set is black. But I can write another fraction statement for this set, can't I? What about this whitish colored stone? Let's write a fraction for how many of the set is white. First, we have to find our denominator. We knew from the previous fraction that there's 4. How many of the set is white? Well, there's only one. 1/4 or 1/4 of the set is white. Okay? Now what if, I'm going to go back to my Connect 4 discs, bring up a few of these. Now what if I gave you a fraction statement and you had to tell me the color? 1/4 of the set is what? What color? Is 1/4 of the set red? Or is 1/4 of the set yellow? Well, if you said that 1/4 of the set is yellow, you were correct. So you would simply write in the proper color there. Now I can write a different fraction statement for that. 3/4 of the set is what? Well, now we count. 3 is the number we're counting. 1, 2, 3. There are 3 red discs. So I would say red. 3/4 of the set is red. Okay? Now what if we did something different? What if I just drew some shapes in here? What if I have a triangle, a circle, a circle, a square, a triangle, and another circle? And I'm going to shade 2 of these shapes. Okay? Now I can ask you, how many, let's see, 2/6 of the shapes are what? Okay, there's a couple answers that could go here. Okay, so what's one thing, if we count 2 of, what is there 2 of up in the shapes up above? Well, you could say 2/6 of the shapes are unshaded. Or, sorry, shaded. My mistake. Or shaded. There's 2 shapes that are shaded. So I can say 2/6 of the shapes are shaded. But there's something else that I can write as well. 2/6 of the shapes are triangles. So if you said either one of those, you were correct. So this fraction statement is now correct. 2/6 of the shapes are triangles. There they are. Or 2/6 of the shapes are shaded. And there they are. Okay? What if there was a baseball team and they had 4 wins and 2 losses? Okay, so this baseball team won 4 games and they lost 2. I want the fraction statement that tells me how many wins they had. Of the games were wins. What is the fraction for the number of games that were wins? Well, in order to write this fraction, I have to find out how many do I have in total. 1, 2, 3, 4, 5, 6. They played 6 games in total. How many of the games were wins? 1, 2, 3, 4. 4/6 of the games were wins. but as you know, I can write another fraction for this. How many, here's my fraction box, of the games were losses? Okay, now, again, we have to find our denominator. That's our total number of games. 1, 2, 3, 4, 5, 6. How many were losses? They lost 2 games. So the fraction for that would be 2/6 of the games were losses. So that's just another way to look at fractions within a set. Okay? Remember, this part here is called the fraction statement, where you give the fraction and then what it is you were counting. That's your fraction statement. And you will see that in your notebook as you're doing your work today. Okay? So, again, if I have 3 up this time, just as a reminder, and I want to write fraction of a set, I want to write the fraction for the black stones, I would write 2 as the black stones out of 3, 2/3 of the stones, or of the set, are black. And that's how you write a fraction of a set. Your denominator is the total number in the set. Your numerator is going to be what it is you are counting. Your fraction statement is the sentence that has the fraction and what it is that you're counting in the set. Okay, you are going to be doing work in your book, so have a good day.